Hi everyone, welcome to Sumanth tutorial. In the last class we discussed about the concept of trigonometric identities based on few simple algebraic identities like a plus b whole square, a minus b whole square, a plus b into a minus b. Maybe I think you are properly learned that all problems. So now today in this session we will be discussing about the algebraic identity related with a cube plus b cube and a cube minus b cube one. So here I'll directly take the problem now. So the first problem is factorize sin cube theta plus cos cube theta. Hence prove that sin cube theta plus cos cube theta divided by sin theta plus cos theta plus sin theta into cos theta is equal to 1. This one you have to prove now. Okay. So whenever we see here cubic terms both, we can directly apply the formula a cube plus b cube. So first and foremost, what we have to do is just simplify this one first. So it will be easy for us to do the problem. So here, solution, what we can write as sin cube theta plus cos cube theta can be written as, what is a cube plus b cube? It will be equal to a plus b of a square minus ab plus b square. So it will be equal to sin theta plus cos theta into sin square theta minus sin theta into cos theta plus b square is equal to what? Cos square theta. Are you understanding, children? A cube plus b cube is equal to a plus b of a square minus ab plus b square. Okay, now directly substitute to this question and directly we will move on to the answer. So the LHS part, what is LHS here given? Sin cube theta plus cos cube theta divided by sin theta plus cos theta plus sin theta into cos theta is given. So this is equal to. So already we are knowing the value of sin cube theta plus cos cube theta, that is sin theta plus cos theta into the value. So directly substitute this one here first. So it is sin theta plus cos theta into sin square theta minus sin theta into cos theta plus cos square theta whole divided by sin theta plus cos theta plus again this one you should not forget. So it is sin theta into cos theta. Got it? Directly just I have substituted the value of sin cube theta plus cos cube theta, that much only. Now see here children, here sin theta plus cos theta is there, here also sin theta plus cos theta is there. Can I cancel these two terms? Yes, of course I can. Next, here as you see, what is sin square theta plus cos square theta? Can I write including that as 1 minus, what is that here? Sin theta into cos theta plus what is remaining next? Sin theta into cos theta. What is minus x plus x? If you see this one, sin theta into cos theta is there with a negative sign, and here sin theta into cos theta is there with a positive sign. Plus and minus will get cancelled out. So what is remaining last is 1 only. So hence the proof RHS. Did we get the answer? Yes, of course. What is the question given? The answer is 1. We got the answer. Okay. I got the board and just we'll move on to the next question. the same time, we will go on to discuss another one problem which is related with the a cube minus b cube. So you can easily understand the concept now. So here I write the question. Prove that tan cube theta minus 1 divided by tan theta minus 1 is equal to secant square theta plus tan theta. This one you have to prove. Generally children, whenever the cubic term is given, as usual you have to apply a cube minus b cube formula. So you may ask, ma'am, here only tan cube theta minus 1 is there, they are not given. So 1 we can write as 1 cube, no. So therefore take LHS as tan cube theta minus 1 cube can be write divided by tan theta minus 1. So what is a cube minus b cube? So it is a minus b of a square plus ab plus b square. Remember the identity properly. So here I will write as a minus b. What is a minus b? Tan theta minus 1 into what is a square? Tan square theta plus here next is what? AB is given, A is tan theta, B is 1, so directly we can write as tan theta enough only. Again plus B square is what? 1. 1 cube, 1 square, everything will be equal to 1 only. Therefore divided by tan theta minus 1. Now the answer has been simplified now. So in the numerator we are having tan theta minus 1, denominator also tan theta minus 1. With the into sign, nothing but by this we can directly cancel out this tan theta minus 1 divided by tan theta minus 1. So what is remaining here is tan square theta. So plus 1 I will take plus tan theta. So children, what is tan square theta plus 1 equal to? It is secant square theta. So by this we can write as secant square theta plus tan theta. Did we get the answer? As the answer is secant square theta plus tan theta. So it is equal to RHS. Hence the proof. So this is how we can solve when the cubic identities are given. Nothing but a cube plus b cube as well as a cube minus b cube. Just make a note of this. Now next, we will go on to solve a new type of problem. Just move on to another type of problem. Can I write? Okay. So here, prove that sin A divided by 1 plus cos A is equal to cosecant A minus cot A. So here, look at the board children. So in the last class I said that sometimes when we have to take RHS part and then we have to find the by using RHS we have to prove the LHS part. The same like problem here, that is LHS is given as sin A by 1 plus cos A. We can't simplify this again. So what to do for this? We have to take the RHS part. Nothing but what? Cosecant A and cot A. So here I will write the RHS part first. RHS is given as what? Cosecant A minus cot A. Don't get confused. One more time I will inform to you. Whenever the LHS part is so simple, which one we can't simplify again. So we can directly take the RHS. Here also you can simplify. Just by rationalizing also you can. But still this method is easy for you to solve. So for that purpose I have taken here as cosecant A minus cot A What is cosecant A equal to? It is 1 over sin A minus what is cot A is equal to cos A by sin A. So here sin A, take the LCM part because both sides we are having sin A. So what will be the numerator part? It will be 1 minus cos A. Is that the LHS? No, no. So for that purpose, what to do? We have to rationalize. Do you know how to do the rationalization, children? So here into 1 plus cos A divided, just multiply the term with the other sign. If it is negative sign, take the positive here. If it is positive, then take the negative here. Of 1 plus cos A. What is 1 minus cos A into 1 plus cos A? It is looking like A minus B into A plus B now. So take as A square minus B square divided by sin A into 1 plus cos A. So here, what is 1 minus cos square A equal to? Can I write this as sin square A? Whole divided, because of the identity, sin square plus cos square is equal to 1. So divided by sin A into 1 plus cos A. Now here, when we write like this, here can I cancel out one sign with another sign A, numerator and denominator? What is remaining then in the numerator part? It is only sin A. What is left in the denominator? That is 1 plus cos A. Is this the LHS part? So it is equal to LHS. Therefore, LHS is equal to RHS. Hence the proof. Copy this one. Just move to another simple problem, children. So see here. Prove that secant A minus 1 divided by secant A plus 1 is equal to 1 minus cos A divided by 1 plus cos A. So what to do for this now? Can I take LCM or LHS part only? So directly I will take the LHS one. So here, look at the board. So here LHS is equal to secant A minus 1 divided by secant A plus 1. What is the value that we can take for the secant? Can we take that as equal to the cos 1 over the cos value? So here 1 over cos A minus 1 divided by 1 over cos A plus 1. Any doubt? No. Next, what to do? As usual, same rule to apply. Take cos A as an LCM 1. So cos A. What is here remaining? 1 only. So write as 1 minus cos A divided by, again cos A, take LCM. So what is here? It is 1 plus cos A. Because nothing is there means 1 times is cos A. So again in the numerator 1 only. So I write as cos A. And I cancel out both cos A and cos A here. So what is remaining there? 1 minus cos A divided by 1 plus cos A. Is this the RHS part? Yes, it is the RHS. So LHS is equal to RHS. Is it not simple, children? Yes, it is of course simple. But if you solve properly, then only it will become simple. Any doubt regarding this? No, no. Can I rub the board? Did you make a note of this one? Yes. So I rub the board. See the next problem. Tan square theta divided by, nothing but here prove that tan square theta divided by secant theta minus 1 whole square is equal to 1 plus cos theta divided by 1 minus cos theta. Okay. So here what is the question given? Tan square theta divided by secant theta minus 1 whole square they have given is equal to 1 plus cos theta divided by 1 minus cos theta. Can I take the LHS part now? Yes. So I'll take the LHS part. So here LHS is equal to tan square theta divided by secant theta minus 1 whole square. Okay, if you are having any doubt, you can comment so that again next class I can explain to you that also. So you can do that. So here tan square theta divided by secant theta minus 1. So how to solve this one? So we know that what is tan A equal to? What is tan A equal to? Sin A by cos A. So in place of tan I write as sin theta divided by cos theta whole square. Now denominator part. What is secant is equal to? Secant is equal to cos. Again nothing but 1 over cos. So I write here as 1 over cos theta minus 1 whole square. Is it clear? Okay. So now in the numerator part, can I write this as sin square theta divided by cos square theta? Because sin theta by cos theta whole square is there. Just I have separated the numerator and the denominator with the square. Now next, what to do for the denominator part? Again how it is looking like 1 over the value and next and the term. So I take the LCM here, cos theta. So it will be 1 minus cos theta whole square. Okay. Now next, sin square theta divided by cos square theta whole divided by 1 minus cos square 1 minus cos theta whole square divided by cos square theta is there. So what to do? Cancel out both here. Okay. If I write here sin square theta, both will cancel, so nothing will be there in the RHS part. You have to each and every step you have to see the RHS part, what it is given, what we have to prove, that you have to analyze, so that only we can solve. So here if instead of 1 minus cos theta whole square it is there, so if you write anything, if you then it will become wrong. So what to do for the next step to get the RHS? See it, the board, just write sin square theta divided by 1 minus cos theta whole square. Can we write sin square theta as 1 minus cos square theta? As I write here, it is equal to 1 minus cos square theta. So what to do for the next denominator part? So here I will write here as 1 minus cos theta into 1 minus cos theta. Can I write? Did we get the answer? No. If I write again sin square, will we get the answer? No. Then what to do for this? So whenever 1 is given, take this as 1 square. Okay. What is a square minus b square equal to? A plus b into a minus b now. So a plus b into a minus b whole divided by again 1 minus cos theta into 1 minus cos theta. Can we cancel anyone? Any term here? Yes, it is 1 minus cos theta in the numerator part, 1 minus cos theta in the denominator part, both with the into sign here. So definitely we can cancel out both. So that what is remaining then? Again 1 plus cos theta divided by 1 minus cos theta is that is the RHS given here as. So therefore hence the proof. Okay, I think we have copied this one. We'll move on to the next problem. So I just clean the board so that we can solve another one problem. Okay, another problem stated is that to solve lot of problem to solve. Maybe you are understanding the problems. So this is all important for the board examination purpose. And second thing is you have to practice well. Then only you can solve the problems. Okay, children. Prove that. The very problem will be prove that only. Prove that cot A minus tan A is equal to 2 into cosecant square A minus 1, 2 cos square A minus 1 divided by sin A into cos A. One more time I will read the problem. Cot A minus tan A is equal to 2 cos square A minus 1 divided by sin A into cos A. So here children, don't get confused. Directly take LHS only. We will get the answer. So see here LHS part. What it is given? Cot A minus tan A. Why I am telling this one? Because cot and tan can be simplified as sin and cos, so that we can simplify it easily. So cot can be written as cos A by sin A minus tan can be written as sin A by cos A. Any doubt here? No. So here, look here now. I said by LHS only we can solve RHS. How we can analyze? You can ask. So how means only by the first step only, as you see the denominator part. What it is there? Sin A and cos A. With the into sign we can take because we are taking the LHS only. So by this we can analyze that. We will directly get the answer as sin A into cos A. No. So here what to do? Take LCM as sin A into cos A. Okay. Sin one time. What is remaining? Cos. So I'll write as cos square A minus. Cos one time will cancel. It will become what? Sin square A. Okay. Next step what do? Cos square A minus sin square is here there. If it is sin square A plus cos square A, we can write as 1. But here it is cos square A minus sin square A is given. Then what to do for this? We got already the denominator part, no? So for that purpose only in the upper part, what is that children? Cos square A is there. So just replace sin square A by cos square A. How to replace? See here now, look at the board. Cos square A minus, what is sin square A? It is sin square A plus cos square A is equal to 1. So sin square A is equal to 1 minus cos square A whole divided by sin A into cos A. Is it right? Yes. So now remove the bracket because cos square A is there. So cos square A minus 1 minus into minus is plus cos square A whole divided by sin A into cos A. Look at the board children. What is cos A? Cos square A plus cos square A? It is 2 cos square A because x plus x is 2x. So here it will become 2 cos square A. What is remaining in the numerator? Minus 1. So in the denominator sin A into cos A. Is this the RHS we should find? Yes. So it is equal to the RHS, hence the proof. Children, now I'll explain to you another different type of problem to solve. So concentrate here. So it is the question given answer. Prove that 1 plus cosecant A divided by cosecant A is equal to cos square A divided by 1 minus sin A. So I said already before only that it is different. So now look here, how it is different, you have to know that. So here, this is LHS 1 children and this is RHS. What we have to prove? LHS is equal to RHS. So now I will take the LHS part first. So LHS is equal to 1 plus cosecant A divided by cosecant A is given. So as usual, whenever cosecant is there, we can change that to sine. So I will change that one as 1 plus 1 by sine A divided by 1 over sine A. Okay. So now, numerator part, just take sine A as a LCM. So that sine A, nothing is there, means 1. 1 into sine A is sine A plus 1 divided by 1 by sine A. Can I cancel out this one? Sine A and sine A? So yes, I can. So here sine A and sine A will get cancelled. What is remaining in the numerator part? Sine A plus 1. This is the RHS we got? No. Is it possible for us to further solve this one? Of course not. Then what to do? Keep this LHS as it is. Okay, what to do? Keep the LHS as it is. Now what to do for this? Take RHS separately. What is the value for this given? Cos square A divided by 1 minus sine A. So you can, so many problems we have solved, but that you can write as cos square A as 1 minus sine square A. So this is 1 minus sine square A divided by 1 minus sine A. In the last problem, I have given a clue that whenever we can't further simplify, nothing but as usual, like if square term is there, 1 is there, if we want sine A plus 1. So what to do for that one? Can we take 1 as 1 square? Because 1 minus sine A is there. If we take 1 minus sine, we can cancel out both. So that I will write this as 1 square. Next all I'll write because you will get confused. So 1 square minus sine square A divided by 1 minus sine A. What is A square minus B square, children? It is equal to A plus B into A minus B. So therefore, I can write this as 1 minus sine A into 1 plus sine A whole divided by 1 minus sine A. Okay, now can I cancel out these two terms? Yes. So what is remaining then? 1 plus sine A. So here in the RHS what we got? Sine A plus 1. Here in the RHS part what we got? Sine A plus 1. So that is RHS is both are equal. As therefore LHS is equal to RHS. Hence the proof. This is a different type of problem in which we will take separately the LHS part as well as the RHS part and we will solve. Okay. Okay children, in this session we have discussed different types of problems related with the trigonometric identities. So now what your thing is, you have to practice these problems well. Learn for the examination purpose only from now itself. And then in the next class we'll discuss few more problems. Till that, connect with the Sumanth tutorial. Then take care.